Good afternoon, students. Good afternoon, sir.
Good
Welcome
afternoon.
to the live virtual classes organized by the Board of Studies Academic, ICAI. Today's session is the Quantitative Aptitude, Chapter 14, Measures of Central Tendency. That is part one of this. That means we are going to discuss, Arjit sir is going to discuss on the important measures of central tendency, and which is very interesting and very useful for the chartered accountant also be in the real life scenario also. There are as kind of like we collect the data, all kind of things actually, how data is collected, and after that information, it can be shown in front of the graphical representation or tabulation form, or various kind of things are also be there. We want to represent the data in a single form, like based on the data also be one that is using that measures of central tendency, which represents the whole phenomenal data also be the average number of students who has passed, the average height, average weight, or like that, average income. It is very important to understand the whole data in a simple language also be. One is like the mathematical measures of central tendencies are there. That is arithmetic mean, geometric mean, and harmonic mean. And positional averages are all like the median and mode also be positional averages. This is about their characteristics, the limits and uh, merits and demerits are also be there, and which has to be discussed here also be. The theoretical point aspects are also very important, and from this topic actually we can say seven good number of questions, means I can say that 7 8 questions are coming from this especially on the topic of the measures of central tendency also be. With his background, sir will be explained very well, no doubt. I welcome you once again, sir. Or
Thank
over to you for the further deliberation, and without wasting my time also be. Students, let us focus on whatever the important aspects sir will be discussing also. Welcome once again, sir.
thank you, sir. Thank you, sir. So, good afternoon to all the students. Good afternoon, sir. And sir has given the introduction to this particular chapter 14 on the measures of central tendency. In fact, chapter 14 has two units. The first unit is on measures of central tendency, and the second unit is on dispersion. So, we are taking up unit 1 of chapter 14 on the measures of central tendency. And sir has given a very important information to all of us, and that is that good number of questions are expected from this part of the chapter, this particular chapter. 7 to 8 questions sir mentioned. So I request all the students to take note of this important information which Dr. Ravi sir has given us. And with that, I will first take up the introduction of what is central tendency. First, we see the structure of the syllabus. So, unit 1, we have the measures of central tendency, and here we will discuss about different types of measures. Like there could be mean, there are different types of mean, median, mode, and so on. So in unit 1 deals with the measures of central tendency. Unit 2 deliberates on dispersion. So in the first unit, which we are taking up today, unit 1, part 1, we will first discuss what is the concept of central tendency. So center means the center of a circle. Central tendency, that means for given data set, what is the representative value which gives us the central part, the central data of the central value of a set of data. So we will look at that, and it can have different types of measures, including mean, median, and mode. We will delve into the properties, advantages, disadvantages, the formula working out the entire computation of mean, median, and mode. Plus, in part 2 of unit 1, which we will take up in the next session, we will cover geometric mean, harmonic mean, their formula, properties, advantages, disadvantages. So please note, as Dr. Ravi sir mentioned, that this is a very important practical and as well as very scoring chapter, and a good number of questions are expected. Primarily, questions keep coming on arithmetic mean, geometric mean, harmonic mean, and positional data, like for example, median, mode, and so on. So this is the structure of the two parts of Unit 1. And as usual, we shall cover and solve a number of questions from the exercises of Chapter 14, the mock test paper, MTP, the revisional test papers, and the past year's questions. Now, what is the learning objective of central tendency? Why are we studying the measures of central tendency? So what is the objective of this chapter? We should have complete understanding of this. So as we see, central tendency deals with arithmetic mean, geometric mean, harmonic mean, and many of these terms you may have learned in your school, even in the school curriculum, both in class 9, 10, 11, and 12. So you may have come across these important terms. Some of you might be knowing even the formula for calculation of arithmetic mean, median, and mode. So the first intention, the objective is to understand the comparative pros and cons of the different measures of central tendency. So we have different type of mean, AM, arithmetic mean, geometric mean, harmonic mean, plus we have median. Along with median, we have quartiles, and of course we have mode. So to understand what each of these terms means, what is the meaning of each of these terms, plus what is the formula, and the objective of this chapter is to understand that in a given situation, in business, in industry, in your career as a CA, many times we have to deal with data. We have to analyze data. So please remember, in the last session, we had covered in depth the understanding of statistical description of data. Plus, if you recall, we had done extensive analysis and discussion on sampling. So sampling, while I was discussing sampling, I was referring to a particular term which is representative. The sample should represent the population. Similarly, in real world scenarios, in industry, in consulting, in economics, we deal a lot of data. We have a lot of data. So from the data, we need to find out which figure or which data represents the entire population. And therefore, this concept is the concept of central tendency, because in any type of data, you will find there is always an average, there is always a center. Average means the middle, like you know that in a circle, the center, think of the center. So central tendency means that in most of the data distribution, you will find that the data are scattered across and around the center. Just like if you find the center, you can draw the circumference of a circle. Similarly, in real life scenarios, the data would be scattered around a center. So this is the central tendency of all types of data, all types of numbers. And therefore, in our particular chapter number 14, which we are discussing now, you can see the entire flow chart of the discussion. Measures of central tendency. First, we will see the definition of central tendency, and then we will delve deep and decode, understand the meaning of mean, median, and mode, which one is the most appropriate in a given scenario. We will analyze and discuss the formula for arithmetic mean, geometric mean, and harmonic mean, plus the properties of each of these measures. Along with that, we will look at median, understand how to calculate the median, what are the properties of median, and then quartiles, deciles, and percentiles. Finally, we will look into mode, understand and analyze the way in which mode is calculated. Plus, we will discuss and cover the properties of mode along with the advantages and disadvantages. So in-depth study of the most important measures of central tendency, along with a detailed understanding of the pros and cons, the positive and the negatives of each of these measures: mean, median, mode, plus quartiles, deciles, percentiles. So it's a very interesting and practical paper, practical chapter of our curriculum, because central tendency is something which we see in every type of data distribution. So what is central tendency? So kindly see, this is chapter 14.1.1 of our study material of ICAI, the definition of central tendency, the first concept. So the tendency of a given set of observations to cluster around a single central or middle. Center, we always sometimes use the word middle. So there are few people standing. Maybe I want to be in the center. So I might say that, can I stand in the middle? So the word center and the word middle often have the same meaning. So central tendency means in any type of data distribution, when you have a set of numbers, a set of data, a set of observations, the observations will scatter and cluster around a middle value. You will have equal or similar number of observations on the left side, on the right side. And this single value or the middle value is what we call a representative value. Sir was mentioning and referring to the term positional value. For example, median is a positional value. So therefore, central tendency is a particular tendency of a set of observations to cluster around a central or a middle value. So therefore, we might have a number of observations. Say, I want to understand the overall performance of a class of 50 students, or say, let us take 20 students. 20 students are there. I want to know their score, the average, the overall score of this class of 20 students in accounts. So as usual, I might go through everyone's individual marks, but a more useful, a more practical manner will be to find out all the marks and add them up and then divide by 20 so that we get the average marks. So the average marks of a class of 20 students gives us an understanding of the general performance. I repeat the word general performance of the entire batch of 20 students. So instead of 20 different marks, one particular central value, say in a class of 20 students, the highest could be say 70, say 85, and the lowest could be 40. And maybe the average comes to say 65. That means from this, the average value, 65 out of 100. So I can understand the overall performance, the general performance of the entire 20 students. So the average gives me an overall understanding, and this is a representative value, and 65 is the average. We are assuming the highest is 85 and the lowest is 40. This means 65 is in the middle. There will be number of students who have scored below 65, and definitely there shall be number of students who will ultimately score above 65. So 65 is an average, is the average, and there will be observations on both the sides, lower than the average, higher than the average. So this is the understanding of what is central tendency. Some of the practical examples, we always ask, what is the average profit of a company? So the average profit gives us an idea. The average market price of a particular share. Sometimes it is not possible to calculate or analyze the last 10 years performance of a company in terms of profit, in terms of EPS, earnings per share, in terms of market price. But an average value, that gives us a lot of background information. So one value which can give us the general information about the performance of a particular business, a particular company, any entity for that matter. So similarly, an educational institution, a professional course. So we always try to find out the average marks obtained by the students. So therefore, central tendency helps in comparison. Most important thing in statistics, comparison between different distribution. For example, I might have two different investment portfolio. All of you, dear students, you are aware about stock market. Many of you are investors. Many of you could be using digital platforms to invest. You know stock markets, you know companies. So there are two investment portfolio A and portfolio B. Now we want to know which portfolio is better in terms of returns. So what do? We will calculate the average return of the shares which are in portfolio A, and we will also compute the average returns of the shares which are part of portfolio B. Whichever value is more, we will say that, okay, this portfolio seems to have or seems to provide, seems to offer higher returns. So the average value or the mean, average is also known as mean. So the mean can also provide us with overall information based on which we can take economic or financial decisions. Even in macroeconomics, mean, median, mode, they have a tremendous practical application, not just in finance, not just in accounts. Even in company law, you will find the average net worth of a company. You will come across phrases, the average profit before tax for the last 3 years. So everywhere, even in law, you will come across the term average. So central tendency is a particular tendency of numbers of data to cluster around a central or a middle value. This could be termed as representative value. So a single average, the average score of 20 students in the CA Foundation exam gives me a summary of the performance of each of the 20 students. So from the average, I understand the general condition, the general performance level of the 20 students. So it is a descriptive summary of a data set. That means from a single value, it could be average, mean, it could be median. We reflect or we get an idea about the entire data distribution. So this is basically what is central tendency. And how do we measure central tendency? In general, as per our curriculum, we have arithmetic mean, of course, geometric mean, harmonic mean, median, mode, and as I was mentioning, the most commonly used measure of central tendency is what we call average in layman's language, but in the mathematical term, in the world of statistics, we use the term mean. The mathematical term is mean. Now we will look at a small example on the right side of your screen of the slide. You can see what is mean. Let us have a quick understanding. I'm sure you all know, most of you already have a good understanding of these three measures of central tendency. But what is mean? Mean is the average. What is average? The sum of all the numbers divided by how many numbers are there. A small example, 4, 5, 6, 3 different scores. So 3 students have scored the marks of 3 students, 4 out of 10, 5 out of 10, 6 out of 10. What is the mean? So you know 4 plus 5 plus 6 divided by 3. Because there are 3 students, so we divide by 3. 3 students, and we get the average score, or the mean is 5. What is median? Median is a positional measure. Why position? Because the median, the word median means, see, MEDIAN, median, is very similar to the word middle, MIDDLE. So median means the middle number. So you have a set of scores, marks, any other data. We arrange them from the smallest to the largest. That means it is in ascending order. We can also arrange it in descending order, where we have the largest observation first, then we gradually go down, and finally we have the smallest number or the smallest observation. So here, the middle number is the median. So please remember, for the time being, that median means middle number. Middle means a position. So please remember seating arrangement we did earlier in our in one of the session on logical reasoning. So in a group of people who are sitting on a bench facing north, we did number of questions. We solved the questions. Who is in the middle? So middle is position, because if you are in the middle, you will have people on your left side, you will have people on your right side, isn't it? So middle or median is a positional value or a positional measure. Now we have 3 numbers. Students have got 3 students. They have got scores 3 out of 10, 5 out of 10, 7 out of 10. So what is the median? So the data we are arranging in ascending order. The smallest is 3, then we have 5, then 7. The middle number, in this case 5. So median is the middle number. So we get median 5. What is mode? Mode means that number, that marks which maximum people are getting. That means the number that appears most frequently is called mode. So if you assume please assume there are 4 students. 4 students, they have just appeared for a class test, and the total marks are 10. One student has got only 2, so doesn't study much. So only 2 out of 10. There are 2 students who have got 4 out of 10. So 4 out of 10 means so 40%. Okay, just pass. And there is one student who seems to be very bright amongst the others. She has scored 6 out of 10. So one student who has got 2, one student who has got 6, and 2 students who have got 4 each. Out of 4 students, if you see, there are 2 students who have scored 4. So mode means that number which appears most frequently. So out of these 4 scores, 2, 4, 4, and 6, the number 4 appears twice. That means we can say the frequency of the score 4 is 2. 2 students have got 4 each. So therefore, mode is 4. I hope it is clear, the basic understanding of what is central tendency. And next, we have discussed what is the basic, what is the overall basic introductory concept of mean, which is also known as average, median, which refers to the middle position, and mode, which addresses or which identifies which data, which value, which number appears with the highest frequency. So these are the 3 basic indicators or measures of central tendency, and that is mean, median, and mode. So now some more examples. We are taking up mean, and we have 2 examples. First, let us see mean is what? How to find the average, how to find the mean. So we had done a very simple example in the last slide. Here we see 2 further examples. The average of, say, for example, the average of 25215. The mean comes to 3. So 2 plus 5 plus 2 plus 1 plus 5. So there are 5 numbers, and the total comes to 15. 15 divided by 5 is 3. So for the first 5 numbers, you see the mean is 3. The average or the mean is 3. Then we have other numbers 8, 10, 12, 18, 22, and 26. Say these are the numbers or the score of 6 students. You can see there are 6 scores given, 6 numbers, 8, 10, 12, 18, 22, 26. Let us assume that these are the scores of 6 students in a class test, and the class test is out of 50 marks. So we find out the average or the mean, and how to find the mean? We add up all the scores and divide it by the number of students. Here the number of students is 6 and the total score comes to 96. So 96 divided by 6 gives us 16. So the average or the mean score is 16. So the mean represents the average value of the data set. You have a set of data, a set of numbers. The average or the mean represents the central tendency. Plus, mean, we will see eventually as we move along the particular chapter. Mean is it's of 3 types. We have arithmetic mean, which we are discussing today. Geometric mean and harmonic mean we shall discuss in the part 2 of unit 1. We will do that in the next session. Today we are focusing on arithmetic mean, median, and mode. Along with that, we will develop a deeper understanding of what is meant by not just median, but quartiles, deciles, and percentiles. So therefore, we can understand that average or mean gives us, or mean is a measure of central tendency, and mean is of 3 types: geometric mean, arithmetic mean, geometric mean, and harmonic mean. We now see another example. So let us take this particular example. On this particular slide, you can see we have number of data. So let us see Virat Kohli's batting scores. So we see innings number is given in a table. You can see this run here score. These are all imaginary numbers. And from here, in cricket, for example, the way in which we identify how great a batsman is, you must have seen that the batting average, the average score, that is an indicator of the person's proficiency, expert level, expertise, batting average. So even in the world of sports, you can see the application of central tendency. So here we see the scores are given, Virat Kohli's batting scores. And therefore, based on these 10 innings, we have got scores. Starting with 50, 59, 90, it goes on. And for the 10th innings, his score is 74. As you can see, each of the score varies. Some are on the higher side, some are on the lower side. So the batting average, if we calculate, we are getting 661, the sum of all these individual runs, 661. And there are 10 innings. So 661 by 10. So we get the average performance, batting average, or the mean of Virat Kohli's batting, overall batting performance. We are getting 66.1. So this is the batting average. So I'm sure that you have understood this example also. This is a very simple concept, average, and we use average or mean in daily life. Now we look at the ideal measure. What should be the criteria for the ideal measure of central tendency? Firstly, central tendency, as we saw, means that the data, individual data sets, are clustered around a single middle value, or it could be the central value. So the criteria is that these measures, whether it's mean or median or mode, any measure of central tendency must be simple to understand, simple to calculate, and it should be defined. Most importantly, it should be defined properly. There should be no confusion in the definition. So what is mean? Mean is what geometrically, or sorry, we use statistical measures. We can simply say that the average of the mean is sigma x by n, where sigma x stands for the sum of all the individual observation and n is the number of observations. So average of mean is denoted by, you can see on the left side of the slide, on the lower side, simple arithmetic mean. So it is sigma x by n, where sigma x means x1 plus x2, because sigma x varies from 1 to n, x equal to 1 to n. So we have x1 plus x2 plus x3. It goes on like this till xn. There are n numbers, and we divide this sum by n, we get the average. Just like if I ask you that what is the average of 7, 5, and 4? Sorry, let's take 8, round number. So 8, 5, and 4. So you will say that, okay, 8 plus 5 gives us 13, 13 plus 4 gives us 17. So 17 by 3, a fractional value. This will be the average. So we get the average by summing up all the individual observations and dividing by the number of observations. Very easy to understand, very easy to define. So we can see that the measure of central tendency must satisfy certain basic expectation, criteria, standard. It should be defined easily and properly without any confusion. Easy to comprehend, that means we should be able to understand easily. We should find it easy to calculate, computation. We should be getting no difficulty. We should not face any difficulty in computation. Plus, it should be based on all observations. So mean satisfies many of these expectations, many of these conditions. Plus, there is one more criteria, and as we were discussing in the beginning of the session, and sir told you that please study all parts of these chapters, including the theoretical part. Even though we are now covering and discussing the theoretical part, we are explaining each of the principles of central tendency. But please remember that questions in the exam could come from any and all parts of the chapter. So there could be a question on, for example, that which out of the following options is not an essential measure of central tendency. So a question could come on this part of the chapter 14.1.2, which we are explaining now. So please be crystal clear about the different criteria which is required for the ideal measure of central tendency. So one of the last point which you see on the slide is that the measure of central tendency should be least affected by the presence of extreme observations. So we will see through an example what is meant by this. So in general, these 6 essential features should be there in the ideal measure of central tendency. Mean. What is arithmetic mean? We are taking up arithmetic mean today. We are discussing geometric mean and harmonic mean. We shall be discussing in the upcoming session. So you can see 14.1.3. It is clearly defined, easy to understand, that arithmetic mean is the summation sigma x divided by n, where n stands for the number of observations. So easy to understand. In case of frequency distribution, where you have different observation, for each observation you have certain frequency. In our earlier session on frequency, where we discussed about the statistical description of data, we had referred to frequency distribution. I was showing through different table what is meant by frequency distribution. You have certain numbers and you also know the number of times this number has come up. The frequency of every observation, that gives you a frequency distribution. In case of a frequency distribution, we get the value like this. The average or the mean will be sigma fi xi by n, where sigma fi means, that means every observation multiplied by the corresponding frequency. That means x1 f1 plus x2 f2 plus x3 f3, like this it will go on. We get the sum and divide it by capital N, where capital N means the total number of frequency. Right? I hope you have understood this. This is the most basic measure of central tendency, arithmetic mean. So it is the most commonly used tool or measure of central tendency. And if it is not mentioned which type of mean we are talking about, then we will assume that it is basically arithmetic mean, because arithmetic mean is the most common type of mean. There are three types of mean: arithmetic mean, geometric mean, and harmonic mean. But arithmetic mean is the most commonly used, probably the simplest amongst these three to understand. And definitely, we always, all of us here, we use the concept of arithmetic mean in different walks of life, both in our personal life as well as in our business, in industry, in commerce, etc. Now we look at the next slide, and here we see the examples. So from the study material of the ICAI, we are taking the first example, arithmetic mean of 3, 6, 24, and 48. As usual, it is simple. 4 numbers are given. There are no frequencies. We just find out the sum and divide by the number of observations. So we get 20.25. Now we come to weighted arithmetic mean. So here, weighted arithmetic means that we have mean from group data. So we see for every observation, we might have a frequency. So please see example 2 on the slide. Certain numbers are given, observations 5, 8, 6, and 2, and the frequencies are given. That means the number 5 has a frequency of 3. That means the number 5 occurs 3 times. The number 8 has a frequency of 2. You can see the number 6 carries a frequency of 4, and the last number 2 has a frequency of 1. So from this, it is a frequency, you can call it a frequency distribution. There are some numbers, each number carries certain frequency. So when we carry out the average calculation, the mean, what we do here is we find out the summation of every number multiplied by its frequency. So as you can see on the slide, please see that here we just find out the frequency. So 5 into 3. The number 5 has occurred with a frequency of 3, so 5 into 3. Then we have 8 into 2. Then we have 4 into 6. And of course, we have the number 2 has a frequency of 1. Accordingly, we get the average, and that is 5.7. So this is also, I'm sure it's clear, and you have understood this. Now we are coming to the next example, where we see that we have now got some classes, 4 to 6, 6 to 8, 8 to 10, and so on. Please note example 3 on this slide, and kindly recall our earlier discussion in the last session, where we were covering and understanding the concepts of the principles of statistical data representation. We had discussed and explained what is meant by class limits, what is class boundary, what is class mark. I'm sure you remember these terms now. So therefore, when we are getting a grouped data like this, how to find the solution? What is the way to calculate the mean? So for every class interval which you see, 4 to 6, 6 to 8, 8 to 10, so you can see this is continuous. There is no gap in between. If there was a gap, then we should have calculated the class boundary. From there, we will get the mid value. But here it is continuous, 4 to 6, 6 to 8, 8 to 10. So we directly find out the mid values. And as you know, the mid value means the middle of the class. That means 4 to 6, the middle will be 5. So the total class interval divided by 2 gives you the quantum of the middle value. So we can find out for every class here. Please see second column now. Mid values are given. And for every class, we already know the frequency. From this, we are getting the mid value X. Column 2, column number 3, we are getting the frequencies as given in the question. And we calculate Fx, frequency into the number. So 5 into 6 gives you 30. Then we have frequency 12, number is 7, 12 into 7, 84. 17 into 9 gives you 153 and so on. So now we sum up the entire Fx, the last column, and what you see is Fx, the summation of the product of individual number and its frequency, that is sigma Fx, comes to 442. This is the numerator. Now please see the frequency, the total frequency. What is the total of the frequency column? N, capital N is 50. So the mean daily wages comes to sigma Fx by N, that means 442 by 50, which gives us 8.84. So this is arithmetic mean, especially for a data set which is grouped. Now we go to the shortcut method. This is also important for your understanding. In case of shortcut methods, the formula is that we will first calculate an assumed, we will first identify assumed mean shown by A, denoted by capital letter A, and we will add, so we have assumed mean plus sigma Fi/di by capital N into C. So we know average is denoted by X bar, or X and then a bar above it. Please remember in the last session on sampling, please remember we were talking about certain terms like parameter, statistic, population mean, sample mean. I hope you remember the last session. Those of you who were there, you will recall that we were referring to certain terms both for the sample as well as for the population. And we were calculating the sample average or the sample mean, the population mean, and so on. So here, you will understand that X bar means the average or the mean, and the formula is A plus sigma Fi/di by N into C, where Fi/di gives you the summation of the individual frequency. Capital N is the total frequency, and class length is denoted by C. We will see example 4 and understand this particular approach for the calculation of arithmetic mean. So here you have a table given 20 to 29, 30 to 39. Please note this particular distribution is not continuous. There is a gap. So you have 20 to 29, there's a gap, and then 30 to 39. So there's a gap between 29 and 30. It is not continuous. And students, number of students are given. So here we see 5 students have got scores between 20 and 29. 11 students have performed between, maybe they've got scores of 30 to 39. Similarly, then the last frequency, if you see the last row of the table, there are 8 students who have received a score between 70 and 79. So what you see is a frequency distribution. So first, if you look at the solution, first column, class interval. So we have 20 to 29, then 30 to 39, 40 to 49, and so on. We can find out the mid values of each of these classes. So 20 to 29, what is the mid value? 29 minus 20 divided by 2. So you automatically arrive at 24.5. This is the mid value of the class. Now kindly observe here, we are assuming, say for example, that the assumed mean, say, is 54.5. So you can see in the second column, beside 54.5, within bracket, it is written equal to A. A means assumed mean. So we are assuming that the out of the mid values which are given, say 54.5 is the mean, assumed. From 54.5, we now find the deviations. So first observation, the first mid value X is 24.5. So what is the deviation from assumed mean? Assumed mean is 54.5 and the first observation is 24.5. So the deviation is how much? 24.5 minus 54.5. This gives us minus 30, which you see in the third column. And you can see this in the first line. Similarly, 30 to 39, please see the second class interval. The corresponding mid value is 34.5. So the deviation is how much? 34.5 minus 54.5, you get minus 20. In this way, for each of the classes, the deviation is calculated. Now let us see the fourth column. Fourth column, you are getting the frequency. In the fourth column, you are getting the frequency, and I'm sure you can see the fifth column is the product of the frequency and the deviation, sigma FD. So the deviation for the first class interval is minus 30 and the frequency is 5. So FD, the product of frequency and deviation, is how much? 5 into minus 30, that gives you minus 150. In this way, for each of the class intervals, as you can see, we are calculating first the midpoint, the mid value, the deviation from the assumed mean, and then we are multiplying that deviation with the corresponding frequency of that class. So what are we getting? We are getting FD, the product of frequency and the deviation. So I hope you're following, you're understanding, and a lot of new terms we are able to analyze, and we will see very soon how we are able to derive or calculate the mean from a complex table like the one you see here. So now we come to the FD part. Sigma FD comes to minus 230. And therefore, if you look at the arithmetic mean, the formula, as I was discussing earlier, is A plus sigma FD by N. So here we have A is 54.5, the assumed mean. Sigma FD comes to minus 230 and N, capital N, is 80. So the average or the mean is, arithmetic mean is 54.5 plus, within bracket, minus 230 divided by 80. That gives us the final value is around 51.6. So in this way, we are able to calculate the arithmetic mean of a frequency distribution. So I hope you're following, you've understood this. Now we take a few examples. Missing frequency, what happens if there is no frequency given? So how to find out missing frequency? So we have example 6 on this slide. We are on slide number 10 now. And you can see the example. We have height, column number 1, and we have frequency, column number 2. For each of the height, 61 inch, we have a frequency 15, 64, 54. And then for the third value in the height column, 67 inch, the frequency is F3. So the actual number is not given. What is the exact frequency in terms of number? It's not given. We are given F3. Then the fourth one has a frequency of 81 and so on. It is given in the problem that the arithmetic mean is 67.45. So you know the arithmetic mean, but you are not aware or you do not know the frequency of one of the observation. Very easy to find out. So what we do, you can see height is given, frequency is given. So let us find out the deviation, and let us assume, say for example, that the assumed mean is 67. So the first observation, if you see, is the height. The first observation in the height column is how much? 61. Deviation means x minus assumed mean. Here x is 61. Assumed mean is 67. Please see the slide. Once again, the lower part of your slide. So what is the deviation? The deviation for the first observation is 61 minus 67, that is minus 6. Now what we do is, as you can see from the data given, 61, 64, 67, 70, 73. So we can say that it seems that the numbers have a difference of 3. 64 minus 61 is 3, 67 and 64 is 3, and so on. So the class interval could be termed as equal to 3. So we got the deviation column, and then we have d dash, which is d divided by 3, because here the class interval, the class length, if you call it, is 3. So we divide minus 6 by 3, we get minus 2, and so on. In this way, we are arriving at the last column now, multiplication of frequency and the d dash for each of the columns, so each of the rows. So for the first row, corresponding to the height of 61 inches, where x is 61, you can see the frequency is 15 and d dash is minus 2. So f into d dash becomes how much? 15 into minus 2, that is minus 30. Okay? In this way, we are calculating the fd dash factor for each of the observations. So for the third observation, 67, we do not know the frequency. But we know that the assumed mean is 67. Accordingly, the deviation is how much? 0, because 67 minus 67 is 0. Finally, we get all the values in the fd dash column, and we find sigma fd dash is 45. We know the formula. We have discussed about the entire approach, how to use the formula for finding the arithmetic mean using assumed mean. So we know assumed mean plus sigma fd dash by the total frequency multiplied by the class length or the class interval gives you the mean. So here x bar is the average or the mean, arithmetic mean. Please note x bar, the value is given. In the problem, it clearly says that the arithmetic mean is 67.45. So you know the value of x bar. We don't know f3. We are not given the value of f3, the third frequency. So by just putting the equation and solving this linear equation, we are able to arrive at the value of f3, and f3 comes to 126. So pretty simple, and just a matter of multiplication and subtraction, because you need to find out the deviation and then you need to multiply the deviation with the frequency. Now, one more problem, very important for exams. We will look at example 9. The mean of two observations is found to be 40. Okay. Later on, it was discovered that a marks of 53 was misread as 83. Find the correct marks. That means the mean of 20 observations is found to be 40. 40 observations are there. The average or the mean is 20. That means we know x bar, which is 40. We know n is 20. So we can find sigma x. The sum is how much? Sigma x, or x for that matter, is 20 into 40. So we have the average or the mean is 40 and the number of observations is 20. So 20 into 40, 800 gives you the total value of the total sum of the observations. It is given that out of these 20 observations, there was one observation which should have been 53, but it was included as 83, wrongly included as 83. So we need to find out the adjusted sum, the adjusted total, or the correct total. This total which we have got, 800, is not correct because one of the observations was wrongly entered in the table. Clear? So what do? We remove the wrong data and we add the correct data. That is what we will do logically. And precisely that is what we have done here. 800 minus 83 plus 53. So we get 770. This is the corrected total, or you can call it, this is the adjusted total, adjusted sum. And therefore the correct average is 770 divided by 20, which is 38.5. So this type of question is important for our exam. Now we look at example 10. The arithmetic mean of 5 observations is 6. Very similar question. After calculation, it was noted that observations 4 and 8 have taken in place of observations 5 and 9. Find the corrected AM. So here again we see the arithmetic mean of 5 observation is 6. So observation N is 5 and the AM is 6. So the total number of observation is 5. So we can find out what is the value of the sum. Sigma x is how much? Sigma x by 5 is 6 because it is given the mean is 6. So we get the corrected total. But first we will get the corrected total, but first we will come across the uncorrected total. The uncorrected total is 30. Why it is uncorrected? Because out of this 30, there are certain observations, there are 2 observations which was wrongly entered. That means 4 and 8, these 2 observations were entered, these 2 observations were included, but the correct observation should have been 5 and 9. That means in place of 5 and 9, 4 and 8 was wrongly, these 2 numbers were wrongly included for the calculation of arithmetic mean. So what do? As before, as we did in the case of example 9, we do the same. The approach is same. The corrected total therefore becomes 30. And from here, from 30, what we do to arrive at the corrected total, we will remove the wrong numbers and add the right numbers. 4 and 8 were included, but these are not the eligible numbers to be included. These were wrongly entered. It was an error. So we remove them. So 30 minus 4 plus 8. And we now have to add back the correct number. So 5 and 9 we are adding. So you get the corrected or the adjusted total 32. How many observations are there? We are having 5 observations. So 32 divided by 5, 6.4. So you get the corrected arithmetic mean 6.4. So I'm confident that you have been able to understand the discussion so far, and we have now done the calculation of arithmetic mean where we are facing certain questions where maybe some of the observations are wrongly entered. So we are finding out first the total sigma x, and then we are adjusting that to get the corrected total. And from there, we are arriving or we are computing the correct arithmetic mean. So example 9 and 10 are important for your understanding and for preparing on this chapter. Now we look at the properties of arithmetic mean. So if all the observations assumed by a variable are constant, say k, then the AM is also k. That means, say in case of a class, if everyone has got, say there are 10 students and everyone has got 40 out of 50. So what will be the mean? Mean is also 40. If the height of every student in a group of 10 students is 170 centimeter, each student is 170 centimeter tall. So what is going to be the average? The mean height. The mean height is also 170. So this is the first property. Very easy. The second property is algebraic sum of the deviations of a set of observation from their arithmetic mean will be 0. That means if you calculate the sum of the deviations, like we were calculating deviation in the earlier example of grouped frequency distribution. So the deviation, absolute deviation, once you calculate the algebraic sum of the deviations. So some of the observations, if you deviation formula was, you remember x minus a. So a is the mean or assumed mean. So when we calculate the deviation of each observation from the average, some of the deviations will be negative, minus something, and some of the deviations will be positive. Once we add them up, we will arrive at 0. So this is the second principle of the property. Now coming to the third very important property, if there are two groups, group number 1 has n1 number of values and the average is x1 bar, and we have another group of members where we have n2 members and it has a value average or the mean is x2 bar. If you combine both these groups, all members of group 1 and group 2, they are combined. So there were n1 members in group 1, n2 members in group 2. Now you combine them, so the combined number is n1 plus n2. The question is, what will be the mean of the combined group? I hope you are able to follow. So what we do here, the formula is pretty simple. The combined arithmetic mean x bar will be equal to what? The arithmetic mean, combined arithmetic mean is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. This is the formula as given in our study material. Now we see example 5 from the ICAI study material to understand and to actually calculate the mean, the combined mean for two separate set of observations. So we have two samples here. You can see there are two samples of size 50 and 100. The mean of sample 1, so n1 is how much? The size of the first sample we have is 50. And the corresponding the corresponding mean, if you see, is 54.1. So for a sample of size 50, the arithmetic mean is 54.1. And for the second sample, this one has a size of 100. So we write N2 is 100. And the corresponding mean is 50.3. So we have got x1 bar 54.1 and x2 bar, which is 50.3. We have been given n1 value. N1 is 50, n2 is 100. So how do we find out the combined arithmetic mean? Exactly as per the formula given on this slide. So n1 x1 bar plus n2 into x2 bar divided by n1 plus n2. So we just multiply accordingly. 50 into 54.1 plus 100 into 50.3, divide it by the total frequency, that is 50 plus 100, that is 150. So we get the combined mean of these two groups of sample, and the combined mean works out to 51.57 approx. So this type of example is very important for the exam. Similar questions have come in the recent past, and you will find very similar problems even in the MTP and the RTP. So not only in the exercises, but these identical problems you will observe even in MTP, in the RTPs, as well as in the past year's question papers. And a very practical formula which we use in real life. Now, another critically important point of arithmetic mean. We are coming to the end of arithmetic mean, and slowly we will move to the median in a couple of 2-3 minutes more. Now we have one problem with arithmetic mean, and that is, if you are given a linear relation between x and y, say y is equal to, say 2x plus 3, something like this, and you know the arithmetic mean of x, what will be the arithmetic mean of y? So here, if you see the property of arithmetic mean is affected due to a change of origin as well as a change of scale. That means in the equation y equal to a plus bx, very important point, please listen carefully and understand this. Number of questions have come on this particular concept earlier. So if you see here, we have y equal to a plus bx, and it is given that we know the arithmetic mean of x is x bar. So what will be the arithmetic mean of y? Y bar. So y bar will be equal to a plus bx bar. That means the arithmetic mean of a particular variable will be affected due to a change of origin. Change of origin here is shown by the letter A. It shows the change of origin, and the change of scale is shown by the multiplier B. That means if you write this equation, now we go to the example, we try to decode and understand the process followed in solving this question. X and y are two variables and they're related through the equation, as you can see, 2x plus 3y plus 7 equal to 0. Fine. It is given that the arithmetic mean of x is how much? X bar is 15. We need to find out the arithmetic mean of y. Very similar questions have come in the past year's exam. So very important. These few problems, properties, and the practical examples which I'm explaining are critically important for the exam. So let us deal with this situation. So y equal to a plus bx, fine. Here, 2x plus 3y plus 7 equal to 0. So I can write 3y equal to minus 7 minus 2x, and therefore y equal to minus 7 minus 2x by 3. And therefore y bar will be equal to minus 7 minus 2x bar by 3. Same. Because the arithmetic mean will be affected due to a change of origin as well as scale. Later on you will find some of the other measures of central tendency, for each of the measures of central tendency, and later on for dispersion, we will calculate and we will understand this particular rule. And there you will find that in some cases, in some particular types of dispersion measures, that particular value of y will only be affected due to a change of scale. It will not be affected due to a change of origin. But for arithmetic mean, it will be affected both by a change of scale as well as by a change of origin. So here the change of origin is reflected by the term minus 7 by 3, and the change of scale is represented by the term minus 2 by 3, which is the multiplier. So the value of the arithmetic mean of y, what will be the value? That will be simply equal to a plus b x bar. And therefore, in the equation, if I put minus 7 minus 2 into 15, because x bar is 15, in one line, I'm getting the answer, and the mean of y comes to minus 12.33. So this is, please remember that this particular problem, the property of arithmetic mean is unique. Arithmetic mean is affected both by a change of origin as well as by a change of scale. Now we look at the last slide of AM, and that is the advantages. Well, advantage easy to understand. I'm sure till now it has been a very smooth journey, and I hope you can appreciate that arithmetic mean is pretty simple to understand. Plus, for arithmetic mean, all the data are utilized because the formula for arithmetic mean is what? Sigma fx by n. That means we have to consider each and every observation. The third advantage, it is capable of further mathematical treatment. We will see in upcoming chapters how arithmetic mean can be used, and we can use arithmetic mean for deriving other measures. For example, later on you will find in the dispersion chapter that there is something called coefficient of variation, something called coefficient of mean deviation. So from the arithmetic mean, other more technical measurements can be made. So therefore, arithmetic mean will be amenable, will be used or can be used for further mathematical analysis, treatment, and data analytics. This is a very powerful advantage of arithmetic mean. And no doubt about it, for two given frequency distributions, arithmetic mean gives us a very clear and a good basis for comparison. So these are the advantages. I hope you will agree to each of them, because we have been covering the analysis, the computation of arithmetic mean through several examples. And now these advantages are self-explanatory, because you can now relate each of these statements with the previous examples which we have been explaining. Also for mean, another plus point, yes, definitely, you do not have to arrange the data. We will see for median, we have to arrange the data in ascending order or descending order. But in case of arithmetic mean, whatever is the sequence of the data. Now say I give you 5 numbers randomly. Okay, so we have say 6 and 8 and 9 and 11 and 14. 6, 8, 9, 11 and 14. I jumble it up and give it to you now. So I give you, I would go like this: 9, 8, 11, 6 and 14. 9, 8, 11, 6 and 14. So there is no clear order. It is not in decreasing order. It is not in increasing order. 9, 8, 11, 6 and 14. Can I find the arithmetic mean without arranging the data? Yes, of course. So I just use, there is no frequency given, so I just sum up all the numbers, 9 plus 8 plus 11 plus 6 plus 14, and there are 5 numbers, so I divide it by 5. That's all. I do not have to arrange this data in ascending or descending order. But later on, in a couple of moments from now, you will see that median is a bit different. Median behaves a little differently. Median, you have to arrange the numbers either in ascending order or in descending order. Otherwise, we will not be able to identify the median. So mean is very simple and has a lot of advantages. However, everything has pros and cons. So we now come to the disadvantages. Okay, now you see the classic example given. Any measure of central tendency should not be affected by extreme values. What does it mean? This we were discussing earlier. So if you see, the problem with arithmetic mean is that it considers all the values, right? We saw this advantage. This advantage can also become a disadvantage. Please see point number 2 under advantages. For counting, what does it say? For counting mean, all the data are utilized. Excellent. But if the data are extremes, like here you can see 2, 6, 2 small numbers, the third number is 301, extreme number. Will the average also fluctuate? Answer is yes, very much. Therefore, you can see the disadvantage which follows, that arithmetic mean, since it considers, it includes arithmetic mean is very decent person. If I think of arithmetic mean as a person, very decent, gentleman. That means arithmetic mean will talk to every friend, will will be very inclusive. They will mix with every person, they will talk to every person, greet every person. So arithmetic mean is very simple at heart, a very good person at heart, and does not distinguish between numbers or people. But this also means that arithmetic mean can be affected by extreme observations. As you can see here, the mean of 2, 6, and 301 is 103. That means the average or the mean of these three numbers show a marked difference. 2 and 6, if you find out the average, how much is that? 2 plus 6, 8 by 2, 4. The mean is 4. But the moment we have added one more number, 301, and this 301 is an extreme observation. You see the scale, the magnitude, 2 and 6, small number, but suddenly 301, big number, extreme. Please see the mean also behaves very strangely, and the mean now becomes 103. So this is a problem. This is a disadvantage of arithmetic mean. So I hope you understand why. And when we refer to the statement that arithmetic mean is affected by extreme value, I hope now every student here in this platform is clear why it means, why the statement is made that yes, arithmetic mean is severely affected, I will say, by extreme values. Okay, so this is, I hope it's clear. Now, yes, arithmetic mean can give misleading impressions in certain cases. Now, yes, like average number of patients could be 10.7, yes, because arithmetic mean is what? Sigma x by n or sigma fx by n. So when you multiply the frequency multiplied by the observation and divide by the total frequency, you might arrive at a fraction. So therefore, we can see the second natural property of AM, which follows from the formula of AM, arithmetic mean. And arithmetic mean can be a fraction. That means it may not portray the right impression or the right fact. For example, if I say 10.7 patients on an average, well, a patient cannot be fractional. A patient is discrete. Number of patients is a discrete variable. It can only assume positive integer whole numbers. You might have 10 patients per day, you might have 1,000 patients per day, you might have 1 patient per day, but it cannot be minus 5 patients per day. You cannot have 10.7 patients coming to a nursing home every day. Fraction, no, you cannot do that. So it may give us a misleading information. So this is basically the discussion of the advantages and the disadvantages. Plus, lastly, arithmetic mean cannot be located by inspection. In a few minutes from now, we will look at median in details, and there you will find median can be located by the inspection. Because what is median? We saw through a simple example in the beginning. Median is a positional measure of central tendency. Median means the middlemost value of the observation, which is in the middle. So just by inspecting the numbers, say I give a simple example here, I cite a very simple example. Randomly, I'm saying, say there are 5 numbers. Let us take 5 numbers. Okay, 7, 1, 4, 9, and 11. 7, 1, 4, 9, and 11. Now, if I want to find the arithmetic mean, I have to calculate. But for the purpose of calculation of median, I just need to arrange them in ascending order. So 7, 1, 4, 9, 11, I will arrange them in ascending order. It becomes 1, 4, 7, 9, and 11. Here I find that the middle value is 7. Please see, the middle value is 7. This is central tendency. You have 2 other values on the left-hand side of 7. You have 1 and 4, which is less than 7. You have 2 observations, 9 and 11, which are on the right-hand side of 7. So just by a mere inspection of these 5 numbers, 1, 4, 7, 9, and 11, I will instantly find out that, oh, hey, the median is 7. It is the number which is occupying the middle position. Well, this is an advantage of median, but when we see it is a disadvantage of mean, arithmetic mean. Right? So this brings us to the end of the first measure of central tendency, arithmetic mean. A plain and simple person, as you could see, not much of computational problem, very simple formula, and pretty simple, a lot of advantages, of course, a few problems, a few disadvantages as well. Now, dear students, we move to median. We already know this person, Mr. Median or Miss Median, if you call. Median, we know this person. Median means the middle. So as you can see on the slide, the word median and the word middle, they mean the same. So therefore, in this example on the slide, 1, 3, 7, 10, and 13. So if I ask you that what is the arithmetic mean, you will definitely take some time to add the numbers. Either you do it using your brain or you use technology for that, but you will take some time. You cannot instantly find out the mean, arithmetic mean, just by inspecting, just by a mere look, just by a mere glance at the numbers. But yes, dear students, the median advantage is just by inspecting the numbers, anyone can say that, oh, 7, the middlemost number is 7 because you have two numbers on both sides. 7 is in the middle. So median, 7 is median. So median is that simple. The concept is that simple. So therefore, median, official definition is, what is median? Median is the middle number in a set of ordered numbers. Be very clear with this, ordered. So it doesn't mean that if I arrange the numbers in a haphazard manner, and if I think that, oh, median means middle number, so middle number. No, sorry. I must arrange the numbers in a particular order, either in ascending or in descending. Okay, so very simple. This chapter is beautiful in terms of practicality, wonderful to study, wonderful to understand, and very, most important, very scoring, because the formula are pretty simple and very common understanding. There's no rocket science here. Okay. So therefore, as Dr. Ravi sir mentioned in the beginning of the session, you may have marked his words. He had said that median is a positional average. This is the detail of that. As compared to the arithmetic mean, median is a positional average. Why? Because the value of the median depends upon the position of the given set of observations for which median is wanted. So therefore, a positional average because it depends on the position. And as we have seen earlier, median is the middlemost value when the observations are arranged in either in ascending or in descending order of magnitude. Okay, fine. Median therefore divides the set of observations into two parts. Like here you can see the median 7 divides the set of numbers into two parts. One part has 1 and 3, the other part has 10 and 13. So the median 7 demarcates, slashes the group of numbers into two distinct parts. And the best advantage, one of the best advantage of median is what? Since it is the middlemost value, please listen very carefully, dear students, to this explanation. This explanation, based on this, several questions have come in the recent year's exam. Since median deals primarily, it's a positional average, it is based on the middle position, therefore it is never affected by large or small observation. That means even if you have extreme observations, median will never be affected. Because median is concerned only with the middle, numbers occupying in the middle. For example, you have seen the numbers here, 1, 3, 7, 10, and 13. What is the median? You will say, yes, sir, median is 7. Why? If I ask you why, you will say, sir, 7 is in the middle. Correct? Now, I replace some of the numbers. Okay, please give me the chance of replacing the numbers. Now, I will replace the numbers and I give you a new set. And the new set is -5, 1, 7, sorry, -5, pardon me, I'll make it -50. Okay, extreme number, -50, -50, okay, then 1, then 7, and then let me think, okay, let me give you a number, say 87, a big number as compared to 1 and 7. And the last number I give you is 1500, a very big number. Extreme. I hope you get the idea. What is extreme number? Extreme value. So the number 1500 is extreme, very large in magnitude, in size, as compared to the numbers 1, 7, even 87. Now, question is, what is the median of these 5 numbers? The numbers are -50, 1, 7, 87, and 1500. So you see here again, the median means the number in the middle. So I'm sure all of you will say that this time also the median is 7. Right? I hope I'm able to make you understand this and you're getting the interest. So yes, median, that means is unaffected by extremely large or small observation. And therefore, if you have open-end classification, you will find median is not affected, because median is concerned only with the middle, observations in the middle. So what is happening on the extreme left side, extreme right side, they are not bothered. Very concentrated person. I think of median as a very, like a saint, like a monk, very concentrated, meditating, only focuses on the center. Okay. On the other hand, Mr. Mean is very jovial, very friendly, talks to everyone. But median talks only to the 2 people or the 1 person sitting in the middle and doesn't bother to look at who are sitting on the 2 ends. You get the point? I'm just adding a little humor so that you see the fun element in arithmetic mean and median, central tendency. So median, therefore, yes, it's a positional average. Now I hope you understand. And therefore, please see what the study material says. In certain sense, median is the real measure of central tendency. Very robust. It satisfies most of the criteria for being an ideal measure. Right? So therefore, we see the next formula now. What happens when the number of observations is both even and odd? We know median means the data set, the middle value of the data set. Fine. So here, let us see the first example and then we see the formula. Before that, please see this line which comes up on the slide. Median is less sensitive to outliers. Outlier is a term you learn everywhere in artificial intelligence, in data analytics, in statistics, in probability distribution. Outlier means out of the ordinary, out of size, odd man out, you can call it. So outlier means extreme values. And therefore, yes, median is less sensitive, or rather absolutely not much sensitive to outliers, and therefore a better measure than the arithmetic mean. Very important information, very important analysis, very significant input. This statement has immense importance and depth, right? So we see now the 2 simple formula and how to calculate the median. So arrange the data in ascending or descending order, find out if the total number of observation is even or odd. Well, if it is even, what happens? So first let us see, okay, let's first take the easier one, odd, okay. If the numbers are arranged in order of magnitude, increasing or decreasing order, and you find that the total number of items is odd, like I give the example, 1, 3, 7, 10, 13. We saw the example in the last slide, and then I changed it by just a more small modification. I said -51, then 7, then 87, and then 1500. How many numbers are there? I've changed the magnitude, the size of the numbers, but how many numbers are there? There are 5 numbers. Is 5 even or odd? The number 5 is odd. That means n, or the number of observations, is odd. So we apply the formula. Median will be the value of the n plus 1 by 2 item. So if n is 5, that means what is the median? Median will be 5 plus 1 by 2. That means 6 by 2. That means 6 by 2 is what? Third. So the third item. As simple as that. In our discussion, we had the numbers minus 50, 1, 7, 87, 1500. Which one is the third number? 7 is the third number. So I hope you understand and follow, right? Now, okay, if you have total number of observations, if it is even, then what to do? So if it is odd, yes, we apply the formula that median will occupy n plus 1 by 2, this position. Now, if you have even numbers, then median will be the value of the n plus 1 by 2th item plus, we have seen for odd numbers. If it is now, if you have even, that means in case of even numbers, say there are 6 numbers. Okay, so we arrange 6 numbers. Okay, 10, 20, 30, 40, 50, 60. We have 6 numbers in ascending order. If you see here, there are 2 numbers which are in the middle, 30 and 40. So for cases where the total number of observations is even, so 2, 4, 6, 8 even numbers, there the median is, which one is the median? The median will be the average value of the n by 2th item and the n by 2 plus 1 item. So here 10, 20, 30, 40, 50, 60. 6 numbers are there. Is it arranged in ascending order? Answer is yes. Fine. Is the total number of observations even or odd? Okay, so n here is 6. 6 is even. So we can say that here n is even. And therefore the median is what? The median will be the value which is sitting. First of all, we have to find the arithmetic mean of 2 values. Which are the 2 values? The values which are occupying the n by 2th position and the n by 2th plus 1 position. Now here we have median, we'll find out the median, 10, 20, 30, 40, 50, 60. Even numbers. Okay, n is 6. So there are 2 middle numbers. First middle number is how much? N by n plus, please see, n by 2. The first item is n by 2. 6 by 2, that is the third item. Third number is, we had the numbers 10, 20, 30, 40, 50, 60. So the third number is 30. So I will first get hold of 30, the first number. Then the second number is n by 2 plus 1. Well, n by 2 is 3. So n by 2 plus 1 is 4. That means I will have to pull out the 4th member, the 4th number, the 4th item. Here, the 4th number is 40. So I am pulling out 30 and 40, and now I will find the arithmetic mean, 30 plus 40 by 2. That means 35. So for these 6 numbers, 10, 20, 30, 40, 50, 60, the median comes to 35. Clear? I hope it's clear. Here again, you can see 2 further examples on the right-hand side of this slide, and you can see this. Let me go back. Yes. You can see median is odd because in the first box, you can see how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers are there. 13 numbers. So here you can see the middle number. Of course, the numbers are arranged in, from the top, if you see, it is in descending order. From the bottom, if you see, it is in ascending order. The median is 12. As you can see, it is identified, it is demarcated by a green border, 12, because it exactly divides the set of observations into 2 parts. It is the middlemost number. On the other hand, on the right-hand side, you see median, and this time we have certain observations which are even. So if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 observations in the right-hand box. 14 observations, 14 is even. And therefore, the 2 middle numbers, the 2 numbers sitting in the middle, we have 27 and 29, and the median is the arithmetic mean of these two numbers. So you get 28. Why? Because the arithmetic mean of 27 and 29 is 28. So please see how we are using the formula and the concept of arithmetic mean in order to calculate the median for a given set of numbers when the number of observations is even, right? Clear. We now move to the next examples. If the marks of 7 students are given, so we see this case now, and we see this case here. If the marks of 7 students are given, then in order to find the median mark, what do? We first arrange these numbers in ascending order, and then we see the fourth item. 68 is the middlemost value. So as you can see in this example, 7 students, 7 is odd, so it is easy to calculate, and we get the median value here. The middlemost number is 68 once you arrange the numbers in order. And you have 3 numbers on the left hand side of 68, and right hand side also we have 3 numbers. So 68 is the exact middle, and therefore the median is 68. Okay. Next we have 8 workers. Please note 8 is even. So the first example we had 7 students, so odd number. So for the next example, there are 8 workers and 8 is even number. And therefore, we first arrange these wages of these 8 workers in ascending order. The numbers are given, but you can see these are given in a random manner. We sort them out in ascending order, and then we see there are 2 middle values, because for even number of observations, you will get 2 numbers which occupy the middle positions. And here the 2 middle values are 96 and 100. So therefore the mean is what? Arithmetic mean of 96 and 100 is what? 96 plus 100 divided by 2. So you get the mean is 98, and mean is now this mean figure, the value which we got, 98. This is the median. Another example, 4, 12, 7, 9, 14, 17, 16. 7 students' marks are given. Please find the median. So we arrange them in ascending order. N here is an odd number. So median will be, N is 7 and N is odd number. So median is 7 plus 1 by 2. That is the 4th value. 4th value is how much? 4th value is, once you arrange them, the 4th value is 12. So the median is 12, right? As simple as this. We proceed to the last 2 slides of median, and now we see how to calculate the median in case of simple frequency distribution. So here we see the table is given, example number 27 from the ICAI study material. You get the observations are given 1, 2, 3, 4, 5, 6, and the frequency Y is given. Okay, we have the frequencies. So 1, the corresponding frequency is 7. So what we do, we find out, we put the frequency according to the table given, and then we find the cumulative frequency. You can see here the cumulative frequency means for the first observation 1, the frequency is 7. So the cumulative frequency is also 7. For the second observation, the corresponding frequency is 12. But for the second observation, the cumulative frequency now becomes 7 plus 12, that is 19. Similarly, the cumulative frequency for the third observation is 19 plus 17, that is 36. Right? I hope you understand how the cumulative frequency table is determined. Here we are given that the total number of frequency, n equal to 100. Well, n is 100, so median we will see, median will be n plus 1 by 2. So it will be the 50, n plus 1 by 2, that is 100 plus 1 by 2th item. So it will be the 50.5th item. So this is for simple frequency distribution. Please note we have frequencies here. And therefore, the median will be the reasoning is from the last column it is found that 50.5 is greater than the cumulative frequency of 36 but less than the cumulative frequency of 55. Therefore, ultimately the median will fall. Basically, the number 4, this will be the indicator of the median, because in this particular cumulative frequency, the cumulative frequency here, n plus 1 by 2, if you calculate, is 50.5. 50.5 means that for the observation 3, the cumulative frequency is 36. But for the next observation 4, the cumulative frequency is 55. So the n plus 1 by 2, 50.5 falls between 36 and 55. So therefore, the median here is 4. Now, the last calculation of median is in case of grouped frequency distribution. That is the last point of our discussion on median. Then we straight away go into mode. Now, let us see what happens for the median in case of a grouped frequency distribution. Let us see this first question. It's a continuous grouped distribution given. You can see here we have the class boundaries 15 to 25, 25 to 35, and so on. The frequencies are given. So to deal with these type of questions, how do we approach? What is our approach which we adopt? So please see the table on the lower right-hand side of the screen. So we have written the class boundary, the frequencies are given. We just do a simple calculation. We find out the cumulative frequency. So for the first class, 15 to 25, the frequency is 4. Cumulative frequency is also 4. For the next class, 25 to 35, the corresponding frequency is 11, but the cumulative frequency is what? The last frequency, the frequency of the last class plus the frequency of this class. So 4 plus 11, that is 15. Similarly, proceeding forward for the third class, 35 to 45, the corresponding frequency is 19, but till now the cumulative frequency was 15. So I add 15 plus 19, I get 34. In this way, dear students, we find out the cumulative frequency. And we observe that the total value, the total frequency comes to 50. Capital N is 50. So N is 50. So what we do is we find out the value of the nth item, and we get the 50th item, that is value of the 20, n by 2, 50 by 2 is 25. Now 25th, value of the 25th item. Now value of the 25th item, if you see, you can understand here that 25 is what? 25, n plus 1 by n by 2 comes to 25. Now, since n by 2 comes to 25, in the cumulative frequency table, you will see that 25 falls between 15 and 34. And here we see, basically it pertains to the class of 35 to 45. Therefore, the median class is 35 to 45. And as a result, as a consequence, we now apply the last formula of median, and we write median equal to the 35. Median class is 35 to 45. So we write L1 first. That is the lower limit of the median class, which is 35 here, plus L2 minus L1 by frequency into M minus C. So L2 minus L1 is what? So we have got L1. And L2 minus L1 means simple 45 minus 35. L1 is 35, L2 is 45. So we write L2 minus L1, which is 45 minus 35. And then we divide that by the frequency of the class. The frequency of the median class is 19. So we divide it by 19. And finally, we multiply that by the factor M minus C. And here M is 25 and C is 15. So from this particular method, we are arriving at the median, and the median class is 35 till 45. the required median works out to 40.26. So this is how we calculate the median. So please remember this formula, n by 2. And there what we do is here we find n by 2, 25, in this case 25. And we first identify the median class, 35 minus 45. And then what we do is simple, that we find out the n by 2 factor, 25 minus 15. 15 is what? 15 is the cumulative frequency of the preceding class. Please see here. The median class is 35 to 45. What is the cumulative frequency of the previous class? It is 15. So what we do is L1 here 35 plus n by 2 minus cumulative frequency of the previous class, 25 minus 15, by the frequency of the median class, that is 19, and then we multiply it by L2 minus L1, which is 10 in this example. That is the class length. So this is median. This is one formula you need to remember, and please practice few problems so that the formula sinks into your memory and you are easily able to retrieve the formula from your memory and solve. This brings us to the end of median, and in median we see the advantages and disadvantages. So therefore median, the best advantage is it is never affected by extreme values of a variable, simply because it is concerned with the middle value. It is a positional average. Number two, it is fairly simple to calculate and understand. Yes, we know middle value. So if you have a series of observations, maybe with a total number of observations could be even or odd, but yes, just by arranging the numbers and by inspection, we can find out the median. We can identify the median. Yeah, median is can be used. Please see the third point. It is capable of further algebraic treatment, just like arithmetic mean. Even median can be used for further mathematical calculation. For example, mean deviation about the mean deviation about median. We can do that. We can calculate. So the median concept can be used for further consequential analysis. So this is a particular advantage and capability of median. So median is also no less, both mean and median are equally strong. However, median scores over mean in one particular situation, and that is median is not affected by extreme values, but arithmetic mean is highly affected by extreme values. Yeah, fourth point, please see. So we are doing it like a story, and we are learning with fun, I hope. And you can see the fourth point is now very crystal clear. Yes, we can identify median just by observation, by a glance, by inspection, if, of course, if the observations are arranged in order of magnitude. Of course, not so easy for grouped distribution, but if it is individual, standalone numbers or data, yes, once you arrange it in increasing or decreasing order, we can immediately identify the median simply based on inspection. Yeah, it can also be determined graphically. Please think of the last day's discussion. Towards the end, you may recall, I was explaining a very critical part of our curriculum, that is ogive, right? Ogive. There you may remember we had earlier discussed on the concept of cumulative frequency, because ogive, you definitely will recall that ogive can be drawn in two manners. You have less than and more than. So less than frequency, cumulative frequency, and more than cumulative frequency. Once you plot these two graphs, you get the ogive, and therefore ogive can be drawn in two ways, no doubt. But when these two graphs intersect each other, the intersecting point, once it is extended to the x-axis, you actually get the median. So you may kindly remember, dear students, that in the last session we had on statistical description of data, we had indeed referred to the word median many times. And yes, now I hope you understand why it is given in the last point, number 5 on this slide, that it means median here. Median can be determined graphically. Yeah, median can be easily determined graphically. One of the examples is through the ogive. Disadvantages, yes, median, no one is perfect. So median also has some fallacies, some problems, and some shortcomings, you can say. So first disadvantage is, yes, you need to arrange the data. Without arranging the data, very difficult. Now, if you have, say, 50 numbers, random numbers, and these are given in jumbled form, can I just look at the 50 numbers and find out the median? No, not so easy. I first need to arrange the numbers. Now, if you have given them 5 numbers, it is pretty easy to arrange the numbers. But if 50 numbers are given, you will take some time to arrange the numbers in ascending or descending order. So unless we arrange it, median cannot be calculated. And median cannot be used to calculate combined median of two groups. Yes, in the case of mean, we saw the formula that if x1 bar is the average of the first group of observations, and the number of observations is n1, and there is a second set of observations, number is n2 with a mean of x2 bar, then the combined mean x bar will be what? It will be n1 x1 bar plus n2 into x2 bar divided by n1 plus n2. This is absolutely possible in case of arithmetic mean, but sorry, in case of median, a similar concept is missing. And therefore, another important point for the exam, I guess a few questions came on this particular theme. For a set of observations, the sum of absolute deviations is minimum when the deviations are taken from the median. That means if you find out the absolute value, mod as we call it, we use a symbol of mod. You can see two parallel lines. Sigma mod xi minus a. That is the absolute value of the deviation. Absolute value means we only consider the positive value. So minus 7, the absolute value is 7. What is the absolute value of 6? It is 6. What is the absolute value of minus 13? It is 13. Ignore the negative sign. So the property says that the sum of the absolute deviations is minimum once you choose A as the median. But if you find out the absolute deviations from the mean, it will not give you the minimum, right? So this is an important principle and, of course, I would say a nature of median. Lastly, we have a similar example, what we saw in the case of mean. If x and y are two variables such that y equal to a plus bx, and if we know the median of x, can we find out the median of y? Answer is yes. It is absolutely parallel and similar to what we did in the case of mean. That means both mean and median are affected by a change of origin and a change of scale, as we discussed earlier in the case of mean. So now we see the case of median, and you can see the problem given. The relation of x and y is demonstrated through an equation 2x minus 5y equal to 10. It is given further that the median of x is 16. So xme, median of x is 16. We need to find out the median of y. How do we do it? So we first arrange the equation in the form y equal to a plus bx. So 2x minus 5y equal to 10, can I write it as 5y equal to 2x minus 10? I can write it. And can I write it as y equal to 2 by 5x minus 10 by 5, that is 2. So I'm getting the expression y equal to 2x, 2 by 5x minus 2. 2 by 5x minus 2. Now 2 by 5x, 2 by 5 is actually the change of scale. And this minus 2 which you see is the change of origin. So now it is given. So my equation now boils down to y equal to 2x by 5 or 2 by 5 into x minus 2. As you can see on the slide, 2 by 5 I've written as 0.4, the decimal equivalent. Now we know the median of x is given, it is 16. So what is the value of the median of y? Well, just put the value of x equal to 16 in the equation and you get median of y is equal to -2 plus 2 by 5 or 0.40 into 16, you get 4.4. So this gives us the value of the median for y. So y has a median of 4.4, which means both x and y are related, and you know the median of x, and therefore you derive the median of y. And on this particular note, you can see that both mean and median have the same feature. Both are affected by a change of origin and by a change of scale. I hope you understand this part. We move to now the concept of quartiles and fractiles. And then we will close with a brief discussion on mode. For Unit 2, we will take up harmonic mean, geometric mean, and a host of questions, solutions. We will be doing it. So quartile. So median is middle point. So quartile is denoted by Q1, Q2, Q3. So quartile means it divides a given set of observations into 4 equal parts. So there are 3 quartiles, Q1 or the first quartile, which is known as the lower quartile. Then you have quartile 2, Q2. This is known as the median. So please remember, Q2 is always known as the median because Q2 will divide the set of observations into 2 equal parts. And then you have Q3, which is known as the third quartile. Okay, so this is quartile concept. First quartile means the value of the observations are less than equal to Q1 and so on. So this is quartile. And now we see what is decile. Decile means a given number of observations now divided into 10 equal parts. So decile, DEC, DEC, these 3 letters, once you read this, you see decimal starts with DEC. And decile, decimal also actually includes, we always say decimal point. So it means point something. And DEC, decile here also means we are dividing it by 10. So values dividing the given set of observations into 10 equal parts, this is what is called a decile. And accordingly, we have 9 deciles from D1 onwards. And you can see that the 5th decile, that means 10, 10, 10, 10, 10. 5 deciles you are going. First decile, 110. Second decile, 110. In this way, once you combine, when you go to the 5th decile, D5, D5 is actually equal to the median because D5 is dividing the entire set of observations into 2 parts. Pretty similar to what median does, and therefore mathematically the 5th decile is also the median. Lastly, you have percentile, percentage of marks. We say, what is your percentage? Okay, I'll say 75% I have got. Okay, so percentile means percentage. Percentage means out of 100. So percentile means the word number 100 comes into the picture. So percentiles or centiles means a given number of observations are divided into 100 parts, and therefore quartile means 4 parts, decile means 10 parts, and percentile means 100 parts, and therefore right from P1 onwards we get percentile. So decile value, how to find out? Very simple formula. Say we want to find out the 4th decile, 4. So we will find out like this. Here I is 4 and 4 by 10 into 10 plus 1. So here we see n is say the number of observations is n and n is 10. So we get, let me take another value, say n is equal to 50. N is equal to 50 and we want to find out the 4th decile. So what will be the expression? 4 by 10 into 50 plus 1. Because n is 50. So 50 plus 1, 51 by 10 multiplied by I. Since we are finding out the 4th decile, I is 4. So it is that simple. And we will see one example. a couple of examples after this slide. And in this way, we can find out any quartile, any percentile, any decile. We move on to see two very critical examples from the study material. One example, we will get complete clarity, and you see this particular question, 14.1.8, example number 14.1.8. A number of observations are given. We have 10 observations. 10 observations are given. We need to find Q1, that is first quartile, D6, that is the sixth decile, and then P82, the 82nd percentile. Very important for the exam. Q1 we know is n plus 1 by 4. If it is Q2, then it will be 2 by 4 into Q1, Q plus 1. If it is third quartile, Q3, then it will be 3 by 4 into Q plus 1, that particular value. So here we have Q1. So Q1 is equal to n plus 1 by 4, 1/4. But n plus 1 by 4, it is 1/4 of n plus 1. Here n is how much? 10. So 10 plus 1 by 4, that means 2.75th value. And we can easily see that 2.75th value means the second value plus 0.75 multiplied by the difference between third and second value. And that's how we arrive at 62.75. Please see that we are first arranging the equation or the numbers in ascending order. Without that, not a single step can be taken. So please remember, whenever you get problems on median or quartile or decile, kindly arrange the numbers in a particular order. It could be ascending or descending. More commonly, we use ascending order. So this is Q1. Now we see D6, sixth decile. What is the value? The sixth decile value will be, here we have 6 by 10. Now here n is also equal to 10. So 10 plus 1 into I by 10. Since it is decile, we are dividing by 10. I is 6 here because it is the sixth decile, and therefore what we do here is we are actually getting the equation D6 equal to 6 by 10 into 10 plus 1. Why? Because it is a decile, so we're dividing by 10. 10 comes to the denominator, and this 10 which you see in the numerator is the number of observations. So therefore, if I just apply this value, I get the 6.6th value. 6.60 we can write as 6 plus 0.6. So what I'll do, 6 means the sixth observation plus 0.6, the remaining fraction, 0.6. 0.6 of what? 0.6 of the difference between the sixth and seventh values. This concept, you know, is interpolation. It's called interpolation. Two numbers to the lower class limit, upper class limit is given. The median is somewhere in middle, somewhere in between. So using interpolation, we are doing it. So here we get the value of 81.20. This is for D6. And for P82, same concept. So we have 82 by 100. Why we are dividing by 100? Because it is the percentile. And numerator remains the same. You can see everywhere it is n plus 1. Here n is 10. So 10 plus 1 into percentile number by 100. As simple as that. That is why this chapter on measures of central tendency is very scoring, because the formula are easy to understand, easy to memorize, and quite easy for calculation purpose. With this, we come to the last part of today's discussion, Unit 1, Part 1, mode. So mode is, we know, we have seen mean, arithmetic mean, and median, which is a positional average. Now, what is mode? Mode means frequency. That means, in other words, popularity. How many people are voting for you? How many frequencies are there? Highest frequency. Well, popularity. So mode is a person who goes by popularity, you know, like you see the rating, the feedback, a person getting maximum frequency, a person getting maximum thumbs up. a person, say in social media or in YouTube, sometimes, number of likes, number of shares. So frequency, how many people are liking that particular video? How many people are reacting to your post? So in social medias like LinkedIn, what you see is the number of impressions your post is making. How popular are you? How is it measured? Simply by number of likes, the frequency. Number of likes, number of shares, number of comments, number of views, number of subscribers. What does it mean? Frequency. So mode, you see, Mr. Mean, we were discussing, very simple person, talks to everyone. Median is very, very particular, looks only at those people who are sitting in the middle, and mode goes by popularity. Okay, so that which occurs maximum number of times. So mode is public demand. Mode, that means in a given set of observations, mode means that particular number which occurs for the maximum number of times. So you may think of this that a particular set of numbers might have more than one mode, yes? For example, in a class of 100 students, there could be a situation that there are maybe 4 students. There are 4 students who have got 70, and there are also 4 students who have got 90. Let's take 90. There are 700 students, and out of them, 4 students have got 70, and exactly 4 other students have got 90. So here I cannot say that the mode is 70 because, yes, even the score 90, there are 4 students who achieved 90. So frequency wise, for 70 marks, the frequency is 4. For 90, also the frequency is 4. So mode also has some pros and cons. But most importantly, mode is easy to understand because it deals with the maximum concentration of observations. So we go by what is most popular, most viewed, most liked. So it is public demand. Think of it in this way. So most common value. So now we come to common value. And say this simple example is given: 5, 3, 8, 9, 5, and 6. So we find in this set of numbers only one number which repeats twice. And the number is 5, which is occurring twice. That means it has a frequency of 2, whereas the other numbers each are appearing only once. They have a frequency of 1. So therefore, yes, mode is easy to understand. But you can see the second point, mode may leave a scope for more than one mode. As I gave an example right now, with a class of 100 students, there could be multiple 4 students getting 70 and yet another 4 students scoring 90. So you may have a bimodal distribution. That means a set of numbers or a set of observations with 2 modes. Can it be more than 2 modes? Yes, of course. It could be a multimodal distribution as well. So please remember, dear students, that bimodal means a distribution with 2 modes. Mode may not be always defined. For example, here out of 5 students, 50, 60, 35, 40, and 56. All marks, if you see all the marks, frequency is 1. So for these 5 students, there seems to be there is no mode because none of the marks are repeating more than once. So this is mode. We are looking at both the pros and cons. Now we calculate the mode, only one formula to remember, and that comes up here. So for a grouped frequency distribution, what do we do? And here again, we will just find out from this example. 36 from the study material, we are now explaining. So you have a continuous distribution. You can see on the right-hand side of the slide, 10 to 20, 20 to 30, and so on. You have the frequencies 5 and then 8 and then 12 and so on. Please remember, for mode, do we need to find out the cumulative frequency? No. For median, if you are given a distribution, frequency distribution, classified like this, yes, for median calculation, we have to compute the cumulative frequency, but for mode, do we need to do it? Answer is no. But we are putting these columns, these classes, these are continuous classes. You can see there is no gap in between, and we have the number of students. Fine. So what we do is, from the frequency, if you see, you will arrive at a particular class 40 to 50. That means 16 students have scored between 40 to 50, which means the class 40 to 50 has the highest frequency. Right? I hope you agree to that. Right? So 40 to 50, we have the maximum number of students who have scored between 40 and 50, which means 40 and 50 is the modal class. This class, the mode is included in between 40 and 50. It is the modal class. The actual mode is hidden between 40 and 50, and we will find out the exact value. So we get the modal class, which is denoted as F1. And the earlier class, the frequency is F0. Here it is 12. And the frequency of the next class after the modal class, we will show it as F2. In this case, it is 10. With these three values, we now proceed to calculate the mode, and we have the mode coming up here. So the mode is equal to, first, the lower limit of the modal class. Here the modal class is 40 to 50, so we write 40 plus. In the numerator, we will just simply write F1 minus F0, which means the frequency of the modal class, which is 16, minus the frequency of the earlier class. In this case, it is F0, and F0 is 12. So 16 minus 12. Denominator, what we do, we multiply the modal frequency by 2. 2 into F0. Sorry, F1. 2 into F1. F1 is 16, so we multiply by 2, we get 32. 16 twos are 32, minus. Now what we do, we subtract the frequency of the earlier class as well as the class after the modal class. So modal class is in between, frequency is F1. The frequency of the class preceding the modal class is F0, here it is 12, and the frequency of the class after the modal class, immediately after the modal class, is F2, here it is 10. So the formula is pretty simple. You have L, the lower limit of the modal class, plus F1 minus F0 divided by 2 into F1 minus F0 minus F2. So in this case, 2 into F1, F1 is 16, 2 into F1 is 32. In the denominator, we have 32 minus the frequency of the earlier class, that is 12, and then the frequency of the next class, that is 10. And we need to multiply this with the class interval. So here the class interval is what? 10. So what we get is 40 plus 16 minus 12, that is 4, divided by 32 minus 22, that is 10, into 10. So exactly it comes to 44, the exact round figure, no decimal. So the mode is 44, which means the mode lies in the modal class, and the modal class is 40 to 50. So I hope this is easy, and you can see we have analyzed each and every point of arithmetic mean and median, quartile, decile, percentile, and then finally mode. Lastly, we look into the advantages and the disadvantages of mode, and we see the advantages. Yes, mode can often be located by inspection. Yes, hopefully, if the distribution has only one mode, you can easily find out. But if it has more than one mode, well, it will be a little challenging. Second, it is not affected by extreme values. Absolutely. Extreme values will have no bearing on the mode in normal circumstances. Is mode simple to understand? Yes, it is simple and precise, both for grouped frequency distribution as well as for ungrouped. Mode is pretty easy to understand, identify, and calculate. Mode can be determined graphically, unlike mean. Mode you can calculate. Think of the last day's discussion, the earlier session, the earlier chapter 13, when we took up the discussion of unit 1 of chapter 13, statistical distribution of data, you may recall, dear students, that we were discussing about the concept of line diagram and then bar diagram, horizontal bar chart, vertical bar chart, and then histogram. If you remember histogram, you will remember that from the histogram, we can easily find out the mode. So histogram is a diagrammatic or a graphical method of determining the mode, and you can find out mode directly from the histogram. Just like for median, ogive is the equivalent, graphical equivalent. So median is linked with ogive and mode is linked with histogram. Clear? I hope you're able to connect and understand. Well, last is disadvantages. Yes. Mode is not suitable for algebraic treatment, and the value of mode is not based on each and every item. Yes. So mode wants publicity, popularity. So think of it, popularity, right? So therefore, mode goes by highest frequency. Mode is not bothered about extreme values, and mode is also not perturbed by every item of the series. Mode is only focused on that frequency or that class or that value which demands or which has got the highest frequency. So that is another peculiarity of mode. And finally, before we close today, we see the empirical relationship. Three friends. We have got three new friends today: mean, median, and mode. We learned about their characteristics, their background, and what type of person they are, right? So now we see, are these three friends related? Can we connect them through an equation? So three friends, okay, mean, median, mode. So we have met all three of them, and we have understood their psychology, how we calculate their the values, and what are their pros and cons, what are their nature. I hope you are finding the discussion useful. But lastly, these three friends, they all have a same purpose. They are all working for central tendency. They are all types of representative value. Are they related? Are they really close friends? Answer is yes. So we now come to the last golden formula. The minus mode equals 3 into mean minus median. So if I transpose this, so I write mean minus mode is equal to 3 into mean minus 3 into median, which means if I take mode on the right hand side and I get mode on the right hand side, on the left hand side, I will bring 3 median and 3 mean. So we will get on the left hand side 3 median and I get 3 minus 3 mean. Just do it yourself, and I'm just writing on paper and just finding out the other side of the equation, the other representation. Mean minus mode equal to 3 into mean minus median. Once you transpose the terms, you get mode equal to 3 into median minus 2 into mean. That is exactly what you see here. Mode equal to 3 into median minus 2 into mean. So therefore, dear students, if you are given the value of any two out of these three, you can find out the third unknown number. For example, you know the value of mode and the value of median. Yes, you can easily find out the value of mean by using this golden formula. Very important. And finally, we see that, yes, mode is also affected by a change of origin and scale, just like mean and median. So all the three friends behave pretty similarly, I will say, and they have a lot of common features. Of course, minor differences are there. But overall, all the three friends, mean, median, mode, they exhibit the same characteristics, especially with regard to central tendency and plus this particular relation y equal to a plus bx. So if the value of say the mode of x is known, or the median of x is known, or the mean of x is known, you can easily find out the mean or median or mode of y. Same relation applies. Both mean, mode, and median, all three of them, mean, median, and mode, they are affected by a change of both origin, and scale. Please remember that. Finally, we close with mean, median, and mode. So mean means the total divided by number of values. Median is the middle number, but you saw that there are some complications. If you have n equal to odd number, if n is even, there are some small changes in the formula. And mode, of course, goes by publicity. So mode is the number that has the highest frequency, and therefore it becomes easy for us to understand and identify that all the three items, mean, median, and mode, our three new friends, exhibit the same characteristics overall, and they are important indicators or measures of central tendency. And one last example of mean before we conclude. You can see in this example from the study material, I thought of including this because it could be a very good example for preparation for the exam. So we are given the classes 50, 59, 40, 49. Yes, we have the classes starting from 50, 59. We are going in the reverse order. And the mean is given 23.5, but the frequencies are not given. It is given in the nature of X. So we have unknown frequency. So how to find out X? Beautiful question from the study material. So we have the classes. Quickly write down the classes. The classes are continuous. Fine. We find the mid value. Mid value means you know that UCL plus LCL. So you know the mid value means what? So you have upper class limit, lower class limit. So we will write, well, upper class limit UCL minus LCL by 2. Other way is UCB, upper class boundary, minus lower class boundary by 2. Both will give you the midpoint. Well, midpoint we are getting for each of the classes, and then we have the frequencies given. We take the assumed mean. So we are using the formula of assumed mean, and here the assumed mean is 34.5. Accordingly, if you see column number 4, it says deviation equal to X minus 34.5. And we see the deviations and we find out the differences. The fifth column shows you deviation divided by class interval or the width of the class. And finally, you have FD dash. So sigma FD dash comes to minus 3x minus 29, as you can see. And therefore, the formula for arithmetic mean is what? Assumed mean, here we'll take assumed mean as 34.5 plus we will take sigma FD square, FD dash, which is minus 3x minus 29. This is in the numerator. Denominator will be sigma n. So it is 6x plus 10. And you multiply that by the class width. And that is how much? This is, well, this is 10. Okay, so 40 to 49, 30 to 39. Yes, so we take 10. And therefore, what we get here is 34.5 plus minus 36 minus 29 by denominator 6x plus 10 into 10. So we are getting x equal to 5. That means the frequency is x is 5. So accordingly, you can find out the frequency of each of the classes given. So with that, we come to the end and a quick summary and recap. We started with chapter 14. There are 2 units, as I explained. First is the unit on central tendency, unit 1. Unit 2 is on the dispersion, measures of dispersion. Unit 1, we have divided into 2 parts. Part 1 we have done today, where we have covered arithmetic mean, or commonly known as average, median, and mode. We have done it in full details. Geometric mean and harmonic mean we are taking up in the next session. Please have a quick glance at this particular slide, where I have given the comparison of the 3 parameters or the 3 measures of central tendency. You have the mean, sigma x by n. And then for the median, we saw if n is odd, then the median is n plus 1 by 2th item, n plus 1 by 2th item. And if n is even, then we take n by 2 and n by 2 plus 1. These 2 items, then we find the arithmetic mean of these 2 numbers. Mode, no formula, simply look at the frequency. The highest frequency gives you the mode. But please remember, mode can be unimodal or bimodal or even more than 2. On the right hand side, we see the last few points we have discussed in detail along with the practical problems. Quartile, please remember there are 3 quartiles, Q1, Q2 and Q3. Q2 is also the median. Decile we have discussed. Decile is n plus 1 by 10 into m. If it is 7, the decile, then m is 7. So 7 by 10 into n plus 1. So that is the concept of decile. Please remember, median is the fifth decile. D5 is median. So median, we are understanding median from two additional point of view. That is, the second quartile, Q2, is also the median, and the fifth decile is also the median. Lastly, we met so many, three new friends. So the three friends are shaking hands. Finally, you can see they are in the same equation. So mode is, or you can put it this way, mean minus mode equal to 3 into mean minus median, which means mode equals 3 median minus 2 into mean. And finally, the quick closer of the session. So sigma x, 2, 3, 5, 6, and 8. So we can get the mean very easily. So we have, next is median. So we have 2, 3, 5, 6, and 8. So the median comes to the middlemost number 5. And for the last observations, we have 2, 3, 5, 5, and 8. So we see 5 occurs twice. So 5 means it is having the largest frequency of 2. So therefore, the mode is 5. So dear students, on that note, thank you very much. And we come to the end of the session on Unit 1, Part 1 of Chapter 14, Measures of Central Tendency. I hope you have followed the chapter, the discussion, the explanation, the analysis. Please go through the video once again, wherever you feel like, pause and once again listen to the explanation, the examples. And in the next day, in the next session, we will take up Unit 1, Part 2. In Part 2 of Unit 1, we shall be delving into the remaining two areas, geometric mean, harmonic mean, and then we will solve number of questions as usual from the exercises and from other sources. So we meet next day. Till then, please go through the video, review the study material of the ICAI, be clear about the distinction between mean, median, and mode, and please practice using the formula for mean, median, and mode, 3 separate formula, especially for the grouped frequency distribution. For mean, please remember the assumed mean. And for median, please remember the specific formula, and also for the mode. And please remember the last formula, that is mean minus mode equal to 3 into mean minus median, right? That's all for today. And with that, I formally end the session and request our tech support team to please conclude the session. Next day, we meet and take up the Part 2 of Unit 1 of Chapter 14. Till then, thank you once again. Thank you, sir. We can close.